Hey, it's Aaron Kohn here once again. Got a couple questions that need answers, and first of all, I'd like to say that the pictures I'm about to show you, they're not mine. I didn't make them. I don't own them. These are all Google images. Um, these are. This is the information that I know, but it's a better way to interpret it instead of me just using my hands or whatever. So here we go. First question was about storm formation. Well, you can get storm formation a couple ways. From a warm front. Warm air coming over cold air, basically forming clouds. It's condensing in the clouds. And a cold front, cold air moving into warm air, pushing away the warm air. So the warm air rises, condenses to form clouds. And here's another way of saying that. Air rises until it reaches its dew point. Well, its dew point. Dew point is basically the temperature at which it makes clouds. And so in this example, you got a temperature of 92 degrees, but the dew point where it'll form a cloud is when you get to 60 degrees. So it keeps on rising and the air expands. And then when you eventually get to 60 degrees in this example, it reaches the dew point. So the air condenses, or the moisture condenses into a cloud. Another way is sun. A lot in the summertime, spring and summertime, the sun heats up the surface and the air rises, and as it rises it cools, and right there is this lifting condensation level, basically where the air condenses, and then that forms a cloud. Now, to form a hurricane, this is an example that I found. Don't know if it's the best one, but basically you got low pressure at the surface that spins around, basically like a tornado, but much larger scale. You got higher pressure aloft, up in the high altitudes, that bring the air back down, and it's a big just circulation. So it rises, condenses, sinks again, and it's just a continuous cycle, if that makes sense. Now, wind shear. Wind shear is basically what it says. It's shear that a change in wind direction with height, wind speed or direction with height. So this cloud here, you may have seen this before. The clouds, if the miles per hour, the winds are faster, then they will blow the clouds apart. If they're slower, the clouds will just keep building vertically or upwards. Here's another example of shear you've seen on just days where wind or clouds are going from like right to left, and in the lower parts, lower clouds, but the higher clouds are going from left to right. So that's wind shear. Here's another example of wind shear, which I will show you in a minute. This shows that the winds are going from southeast to northwest at the lower levels, and in the upper levels they're going from west to east. So change in wind direction or speed with height. Here's an example. This is the Dulles Airport near Washington, D.C. At the lower levels, wind shear or wind going from west to east, but the upper levels, they're going pretty much the same, so there's not much wind shear in this particular example. Cloud formation. Here's a couple ways that physical geography affects the weather. The air rises up the mountains to form clouds, or the converse, or the inverse, wind comes down the mountains to form to have warm air. Now here's my favorite example is cold air damming. Cold air dams across the mountains here, and is able to bring lots of snow into the area. So if that makes any sense, you can research more. I hope this helps, and please subscribe. Thank you.